This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we support design engineers and make lightning protection easy. You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Aerospace Engineering Podcast. I'm your co-host, Dan Blewett. On today's show, we've got number one, something for Alan to really dig his teeth in. We've got some issues with Airbus aircraft and their lightning protection systems, some paint peeling, some controversy over expanded metal foils, and there's a pretty heavy dispute between Qatar Airways and Airbus, so we'll dive into that. We're going to talk about the Dayton Zoning Board has voted to demolish the site of the Wright Brothers' first bike shop. Disappointing decision, obviously, for a huge innovators in aviation, the grandfathers of aviation. We'll talk about United deciding to put passengers on a SAF flight, not completely SAF, but one engine will be completely powered by sustainable airline fuel. Also seems like a curious decision. We'll talk about Pratt. They've announced an update to their A320 Neo Engine. It's going to have more thrust, and we'll see how that might affect their sales and their efficiency. And lastly, in our EVTOL segment, we'll talk about Sydney Seaplanes striking a big deal for 50 aircraft of Eve Urban Air Mobility's four-passenger EVTOL. They do a lot of commuter and tourism flights down in Australia, so it sounds like a really interesting proposition there. And lastly, we'll talk a little bit about Joby's simulator, which, Alan, that lacks foot pedals, right? It doesn't have a rudder. Is that right?
It's a totally different configuration than most airplanes.
Yeah. Seems really interesting and unique, to say the least. So let's start with Airbus and Qatar Airways. So Reuters has obtained a number of photos which are pretty shocking. They make this seem like almost a homebrew thing. Like, you don't see paint peeling this badly. Qatar is very unhappy with Airbus, and both sides are sort of in a little bit of a tug of war about, what's going on, who's going to fix this, and how big of a deal this is. Yeah,
so the A350 is primarily a carbon fiber airplane, and like the 787. So they're comparable airplanes in that sense. And what Airbus has done is they've used an expanded, what the articles say is expanded copper foil as lightning protection. And so what you do is on the top layer of the carbon fiber, you sort of embed this mesh, this copper mesh into it, and that acts as your lightning protection. And then that mesh gets over-coated with paint, so the outer surface looks white like most airplanes do. So you kind of got this three-layer thing. You got the outer layer of paint, this expanded copper foil, and then carbon fiber structure. So the system has been around a long time. That's a 40-year-old kind of design. And one of the issues with any expanded foil is paint adhesion. It can be problematic at times, particularly if you have a repair. And what these photos indicate is like they had some small repairs that happened around the airplane that they tried to fix. And there's standard repairs which happen. So as you're sanding, grinding away on an airplane to make all the parts fit, it's not unusual that you damage or sand into some of the expanded metal that's on the surface, and then get into a repair situation, which the repair is to put more mesh on top of it to add back the connectivity which you've removed. When you do that secondary process of sticking on metal, and it looks like from some of the photos, it looks like it's aluminum mesh, not copper, that was stuck on there secondarily, is that you just don't get it adhered properly. And over time, temperature, flexing, that kind of thing can cause the mesh to kind of pop off, and it takes the paint with it. So the paint doesn't like to stick to it, and then the mesh doesn't like to stick to the airplane. And that's what the photos indicate that Reuters has put up on their website. So that's I would say that's not unusual. It's unusual today in the sense that you don't think you see it coming off a production line. You tend to see it on airplanes that have been around a lot longer in flight. When the Beech Starship came out back in the late 80s, early 90s, they had an issue very similar to that. Pretty much every composite airplane or composite part with mesh has some sort of issue with paint adhesion because of the mesh that surround it. particularly on the cut edges of parts. So like where the mesh can be exposed as you cut along a trim edge, that can corrode or cause problems. It's more cosmetic than it is a lightning issue. And in these particular cases, the mesh looks to be visually, to me, to be just a cosmetic thing, not anything critical in terms of lightning protection. And the way you know that that's not so much usually critical here is the mesh. If the paint's off carbon fiber does well with lightning strikes. It's the problem when you paint the carbon fiber that carbon fiber doesn't do so well. And the mesh is there to sort of bridge that gap.
And real quick, why is that, Alan?
The paint controls and limits where the lightning will go. It basically forces it into a smaller area. And the carbon fiber, which is great at handling energy, just can't handle that much focused energy in a small spot. And that just causes the resin to burn off and the carbon fiber to kind of burn off and do all this bad stuff. So once you paint carbon fiber, the damage gets deeper and just more expensive to repair. We put the mesh on it, it keeps the damage light on the surface where you can kind of scuff it, fix it, repair it. That's why you use the mesh a lot of times on sort of non-critical things, airplane structures, is that it just keeps the cost down on maintenance. So this one is really interesting because it's been seen at several airlines now, and Airbus is trying to address it, but you're in this really weird spot where I think you got a brand new A350 and you're already trying to fix the paint on it. And more than likely, the maintenance crews at these airlines have been trying to repair it and maybe not prepare it the way that it should be repaired. And they're having sort of this continual problem go on, thereby making the problem worse. And Airbus is like, whoa, probably like, whoa, everybody slow down a minute. We don't have to fix this straight out. It's not a safety issue. We could come back and address it, but it's expensive.
Well, EASA has proposed an Airworthiness Directive that the expanded copper foil, there could potentially be an issue if a cocktail of factors comes together. Adjacent fasteners incorrectly installed, then a big lightning strike, then they're saying maybe fuel vapor could be ignited. That's obviously aircraft design? They have to look toward those crazy what if
right.
kind of scenarios.
Right.
I mean, is that realistic? I mean, what's going to be the action item here? Is EASA going to make them fix this, or what's going to go on, Alan?
Maybe. When we talk about fuel tanks, there's more criticality and more focus on fuel tanks because of the consequences. If you get a spark in a fuel tank with the right temperature and right fuel-air mixture inside of that tank, like we saw years ago off the coast of New York there, the fuel tank can explode. And from the lightning protection side, you do a lot of protection in the fuel tank area, combination of meshes, foils, fasteners, fastener types, all kinds of sealants on the inside. There's all kinds of layers of protection that go onto a wing. If the foil is having trouble and the foil's not installed properly, or the foil has been damaged during manufacture, like Boeing had some of that happen on the 787 on the wing also, then you're losing a layer of protection. So instead of having essentially 3 layers of protection, which is kind of typical, you get knocked down to 2. So there's just less protection there. But you also have to have, less protection, something really go wrong, a lightning strike in that particular area. So the chances of that being a serious issue are practically zero. And that's why no one's freaking out and grounding airplanes right now, is that there's so many layers of protection that Airbus has designed on those airplanes. It can handle some of these defects and allow them to go back and repair them. So that's what's happening right now. Yeah.
And of course, Qatar Airways has grounded 20 of its 53 A350s. But it seems like they're kind of acting on their own, like a little bit. Like it says they have their own regulator.
They do.
Alan, what's the deal with Qatar? Why are they? It seems like they're acting completely separately from everyone else on this issue. Like Delta has some issues, I think, with one plane, but Qatar seems to have the biggest problem.
Yeah, and everybody has their own national regulator for the operations side. So when you're in America, the airlines operate under a different set of codes or regulation on how you maintain the airplane, operate the airplane, blah, blah, blah. So what Qatar is saying is that our national agency, Airworthiness Agency, is saying this may be an issue, but that's all this is political at that level, especially about the money you're talking about, and the consequences are big for any airline if you have to take airplanes out of service. So it becomes part engineering, part political, with some finance things thrown on the back side of it. So it's never just an engineering problem. Never.
All right, so moving on, the Wright Brothers, obviously their first bike shop is in Dayton, Ohio. And I suppose nowadays it's been, their shop has been vacant for years. And looks like back in 2008, it was declared a public nuisance. Disappointing that this shop hasn't been preserved, and held as a historical, how many places like this have been made into museums and cool places for people to be, right? But anyway, this one has not. And it looks like city officials are now declaring that they're going to demolish it. Alan, and I think some of the other historical sort of monuments to the Wright brothers have been moved. What's left now in Dayton for the Wright brothers?
There's not a lot in Dayton. Obviously, the Air Force has its museum, Air Force Museum in Dayton, which is massive and beautiful. And if you ever want to get lost for about 3 days, go wander through that. But in terms of the Wright brothers, there's not a lot there because Henry Ford I think they bought their family home, and I think the shop, the bicycle airplane shop, I'll call it, and moved them up to Dearborn, Michigan. So everything's up in Michigan and out of Ohio. There's not a lot of Wright brother stuff in Dayton anymore. Obviously, that became a big center for aviation because of the Wright brothers were being there, which is now sort of an Air Force thing. But there's not a whole bunch of stuff. And it wasn't that long ago. We were in Dayton itself. We went to the Air Force Museum, and I've been there a couple of times, but I've never spent any time hunting around for Wright brothers stuff in Dayton, because when you go there, there's no, maybe I'm wrong. I am just a generic tourist at that point, but I would think I'm your key traveler in that marketplace. I'm the person that would want to go look at cool aviation stuff, and there isn't much Wright brothers stuff there. I think we did go look around a little bit, but yeah, it's sort of sad.
Yeah, and of course, some opponents of the demolition of this building, and of course, they've deemed the building structurally unsafe. But people are still saying, hey, can we redevelop this and, use the original facade? Which you see projects like that all over the place, right? Which are really cool. And but then again, I don't know the overall topography of Dayton, and if that would really make any sense. This, might not be in an area where redevelopment makes a lot of sense. Who knows? But it would be cool if they could do something like that to preserve it.
And the Air Force in the military has done a decent job over the last couple of years of trying to develop the Dayton area. So I get emails all the time about Dayton startups and Improve Dayton, and bringing new energetic engineering type aviation companies, space companies into Dayton. There's a big promotion to do that, but Dayton's obviously going through a transition like a lot of former industrial towns. So this is just par for the course, unfortunately. And you think that someone would step up, like, Bezos or Musk or somebody would step up and say, well, here's $1 million, go fix the building. But that hasn't happened, weirdly enough.
All right, so moving on, last week on December 1st, United flew the world's first passenger flight on 100% sustainable aviation fuel in one of their engines. So this 737 MAX 8 flew from Chicago O'Hare to here in D.C. to Washington Reagan National. And of course, there were two CEOs on board. United CEO Scott Kirby was on the flight, as well as GE Aviation CEO John Slattery. Alan, the big question is, why did we need to put 115 paying passengers on this flight? I mean, what did that tell us, and is that safe?
It didn't tell us anything, I hope. It's just this sustainable fuel piece is interesting, because I thought, am I wrong still that there's a limitation, that it's 50%? It's the maximum amount of sort of Jet A sustainable fuel that you can fly at the moment. But in this particular case, they basically filled one there's essentially two fuel tanks in a 737. So they filled one side up with sustainable fuel and the other side up with Jet A. So you got two engines burning slightly different fuels and put passengers on it. I'm sure it was FAA approved, just it had to be. But it just feels weird, doesn't it? Like anytime they say test flights and you got paying passengers on it, that doesn't ever feel PR-wise like a good movie. Test and paying passengers are not the combination that you want in a PR. And that's what I think. Dan, am I wrong?
No, you're not wrong. And of course, on this flight, you're right on the 50% SAF limit. And because one engine had 100% SAF in it and the other had 100% Jet A in it, that equals the 50%. So that's why they did this. But rather than blend it, they just did 100% in one engine. So interesting way to stay within specs, I suppose. But that doesn't seem like that's the same thing, as you've said, because the hydrocarbons that you're burning in each are very different.
Yeah, or they're slightly different. What United and GE are saying is that, well, a fuel molecule is a fuel molecule. The engine doesn't care. Well, yeah, it does, because there's all kinds of additives and other pieces to the fuel mixture that make it perform the way that it does. So I'm sure this is completely safe. It had to be, but the visuals on this are not great. I just don't understand.
Yeah, well, it's one of those things that has very little upside potential and just insane downside risk, right? If something had happened, people would be like, this is a baffling decision.
Why?
Like,
Right?
in what world did we need to, these 100 plus people, and the upside was a happy press release, like one insignificant press release that lasts one day in the news cycle,
Well, yeah.
Of course, I do appreciate that the CEOs were on board because, as we've mentioned a little bit in the past, it's good to have skin in the game, right? Back in the day, people used to be held criminally accountable for their work. If you're a bridge builder back in, I don't know, sometime in history, if that bridge collapsed and killed people, you were going to be in serious criminal trouble, if not maybe killed yourself. Not to say that's right, but the CEOs are on board. They're like, hey, we believe in this too. And obviously, the best example was the bulletproof vest. The bulletproof vest didn't catch on until the inventor of it took a revolver and put it to his own chest and pulled the trigger. And that was a heck of a moment, if you've never seen that video. But so at least they were there. And obviously, this went off without a hitch, so no big deal. And like you said, I'm sure they knew that. Not with like 99.99999% certainty. But still a little bit of an interesting decision. So let's move on to Pratt. They've announced a update to their A320 Neo engine. They've added thrust to it. It's going to boost their fuel efficiency by 1% with 4% higher thrust when it rolls out in 2024. Alan, how are they going to do this, and how do engine makers, continue to just squeeze more out of these engines?
Computers and technology, those are the two. If they've made some slight changes to the compressor section, which they probably did in terms of maybe some aerodynamic issues or improvements in terms of the way that the air fuel mixture is burned, maybe run a little bit hotter. I mean, that's one way to do it. To just get better fuel efficiency out of it and more thrust. I'm always amazed at these engines when they first come out. They seem like they're kind of derated a little bit, and probably that's the right move, right? You want to get the engine in service a little while, get some history on it, get some flight hours on it, make sure everything's working right, and then they start slowly removing those restrictions and getting more and more and more thrust at it. So if you watch the evolution of any particular engine, it just goes up and up and up in thrust. And the GE, 9X, GE90 formerly, the thrust on that went up crazily over time. and then Pratt & Whitney is doing the same thing, obviously. But it's just a wonder when there's a talk about efficiency and sustainability of aviation, you point to stuff like this. Like, aviation's done a really good job of moving people efficiently, and it gets more and more efficient every day, because every engine manufacturer and every airline's looking for fuel savings and better performance.
Yeah, I think that makes sense the way they kind of roll it out a little bit on not underperforming, but This is, I think, a good baseball analogy is when you are trying to get a scout to come watch a kid, say as a pitcher. Say the pitcher can throw 95 miles per hour some days, but not most days. And he'll probably get there in the future. But today, he usually throws 90 anytime you see him. So instead of saying, hey, I got this kid that throws 95, which potentially opens him up to the scout being disappointed, you'd say, hey, I got this kid who can throw 90. He comes out. If he's better than 90, wonderful. He's impressed. And at the worst, he's going to be what he was advertised to be, right? Is that kind of how they do this with these engines? Like set expectations to a reasonably low but still high-performing level, and then they can always exceed?
Yeah, and the way that the airframers usually pick an engine, they'll obviously pick it on thrust and cost and some other factors, familiarity with the manufacturer. As airplanes get developed, they always get heavier. And I think the engine manufacturers know that. So they have some reserve in the engines. And you have to go back and say, hey, Pratt, we need another 10% thrust so we can get our airplane off the ground. And then Pratt goes, oh, it's going to be hard, but we'll try to make it work. And then magically, 6 months later, it has more thrust and your airplane project's off the ground. So they know how airplane designers work. Yeah, airplanes never meet their initial weight, no matter how they do it. And then the engine manufacturer's got to suck it up and get the airplane sold. Just need more thrust. That's how they do it.
All right. So moving on to our EVTOL segment today. First on the docket is Sydney Seaplanes, and they're planning to hit the tourist segment of the market, and they've teamed up with Eve Urban Air Mobility to do that. And of course, that's Embraer's arm. So they are agreeing to add 50 of their 4-passenger EVTOLs, and that's going to be around 2026 is their anticipated delivery date, I suppose. So, Alan, it seems like Sydney Seaplanes does a lot of tourism. They do a lot of flights, just motoring people around, seeing the beautiful country, the beautiful coastline. This seems like a use that we haven't really heard that much about in the EVTOL space, but it seems like a great use for it. Short flights, you don't need 3-hour time in the air for you to shoot around and see a lot of beautiful sights.
Right, and this is a perfect application for electric aircraft. And we've seen some of that in Hawaii recently on some of those little shuttle flights where they've converted the Skymaster, Cessna Skymaster. One engine is internal combustion, and I think the rear engine is electric, if I remember that correctly. And then there's been some work over in Europe doing something very similar. But these little shorter flights make a ton of sense, and also because of the reduced maintenance costs. Because if you're making a lot of shorter flights, they can have a lot of wear and tear on an aircraft, and the electric motor should reduce the operating costs a great deal. But this Sydney firm also had an accident a couple of years ago. I was reading some of the details of it, where they had essentially carbon monoxide poisoning of the pilot, and they had a crash. And when switching to electric will eliminate that as a possibility, you would think. So it seems like a really good mix of improvements in safety, probably reduction in operating costs, operating expenses, maintenance, reduced maintenance, and quieter experience, probably, as the aircrafts are going to be quieter. So this really fits that niche that the electric aircraft should be fitting into. Aircraft trainers, which I think is Bio Aerospace is doing, which makes total complete sense. Again, it's a maintenance operational thing. There, sightseeing, go Cape Air. Cape Air is the other one too. Out of my neck of the woods in Massachusetts is going to have some electric aircraft to shuttle people back and forth to like Martha's Vineyard, Nantucket, that kind of thing. So there's going to be a lot more of these shorter flights, and I think that's the right answer. Instead of flying New York to Los Angeles or New York to London, I think you got to start smaller and figure out how these systems operate, and then expand it over time. And hopefully that's the direction this will go. Do you see that too? That's going to be the first entry market. It's not going to be Uber. It's going to be probably sightseeing.
Yeah, I think it makes a ton of sense. I mean, you can, rather than having to worry about getting from point A to point B, and how do you recharge at point B? Like, you need a second. Obviously, there needs to be infrastructure to everywhere you land. But here, you're just making a big old loop and coming back, where you've got your own fleet of them. So you've got all the batteries you need. You've got all the charging stations you need. You can set things up exactly how you want. So you can rotate planes while one's charging back up or whatever. Yeah, it seems like it makes a ton of sense. You can be really self-sustaining in your own little ecosystem. And I think people would be really excited to take a next generation plane around. I know I would. If the option was take an EVTOL around Sydney or take a helicopter, I'd take the EVTOL for sure. You're like, whoa, that's cool. Let's do the futuristic one. And like you said, it's gonna be quieter. It seems like a great idea.
Yeah, I think that's where it's going to find a sweet spot early on. Electrics are. And also on the cargo, I think there's going to be a decent amount of little shuttle flights for cargo, which electric makes sense for also. Again, Dan, back to your point, flying to A to B, B to A, fixed points, I think that makes total sense for. So there is definitely a marketplace. It just may not be as visible to you and I. We're not going to Chicago on an electric airplane in the next couple of years. We're going to be flying a standard 737 type airplane or A320 type airplane. But that's okay. That's okay. You got to start somewhere and you got to figure out the technology. And this is, I think, the best way to do it.
So last on the lineup today, there's an interesting article from AIN Online about flying the Joby EVTOL, flying it in their simulator. So Alan, one of the unique things about the Joby aircraft is that it's very different because it's a tilt rotor, and B, it doesn't have rudder controls, foot pedals, that kind of stuff. Is that right? So I mean, what are the key differences when you would hop into something like this?
Obviously, there's a lot more sort of engine management things going on because you've got these 6 motors, propellers spinning all the time, and they're using a Garmin 3000 series flight display system. But essentially, you have 2 controls: a thrust and a direction. So on your left hand's a thrust, on your right hand's direction: up, down, left, right, forward, back. Yeah, pitch. Depends what kind of flight mode you're in. So it flies like you would fly a computer game on an Xbox. So this may be the first Xbox generation airplane, just because of the way it flies. And one of the interesting things they talked about was the aircraft. When you bank an airplane, it tends to stay banked like a standard airplane. You put it in a turn, it tends to stay there. Take your hands off, it tends to stay there. Or any kind of configuration on an airplane, you point it in a direction, it'll keep going that direction. And this aircraft, it wants to come back to neutral. So it's always seems to be kind of coming back to neutral, which is unusual for pilots. So there's a lot of, it may be intuitive for a kid who's never flown an airplane, but I think for a pilot, that would take a little bit of time to figure out. Plus the lack of rudder pedals would be odd. I think, like, what do you do with your feet? Because you do a lot with your feet on the ground. Well, one, you steer the airplane. That's how you get it moving around as you taxi, is with your feet. But then, so I always wonder if what has evolved in terms of flight controls today is driven only by engineering, or is it a combination of engineering plus human reaction, comfortability things? It goes back to like there's a big discussion about Tesla and their little steering wheel. It's not round anymore. It's just kind of got the yoke. It's got 2 handles on it. The yoke. Yeah. The yoke. Right. Okay. So there's a lot of discussion. Like, some people like it, some people really hate it. And I think, okay, you could really hate it. That's fine. But is it an improvement on safety? Is it less safe? I think there's arguments made on both cases. And I think with Joby, if you're taking pilots that have, say, 10 years of flight experience in, piston airplanes or King Airs or whatever kind of airplane, or jets, or flying a Citation or something like that, I think it's going to take a little bit of time to transition into this different flight configuration. So, I mean, that was part of the Part 23 rule change that happened a couple years ago, 2017, where they tried to be less, the regulations were less prescriptive about what the airplane's supposed to look like, and just said it needs to perform like this. Inside this box, you can do things, but as long as you don't go outside the box, it's fine. And that's the way the rules are written right now. So I think Joby is taking advantage of that and saying, okay, let's rethink the way we interface with the pilots. But again, it's sort of jury is out. Is it as safe, less safe, same amount of safety, better safety? Who knows? Until we get some more flight time. And we haven't, Joby hasn't put, at least to my knowledge, Joby hasn't put a real human pilot in the airplane yet. So we don't even really have any feedback besides simulator today. So I'm curious as you get to flight test pilots getting in an airplane, especially as you get more and more airplanes built and you put more and more flight test pilots in it and ordinary pilots in it, what that outcome looks like. Don't you? Can you see how that can be confusing in someone's head? Like, I know how to fly this way, but this airplane reacts differently.
Yeah. And of course, this article by Matt Thurber, he was the one invited to try out the simulator. He had seems like a remarkable experience. I mean, he said, here's a quote. He said, "I've never felt so in control of an aircraft and so free to focus on flying tasks rather than on constant control manipulation. This was like flying a fictional, imaginary, perfect aircraft. I can't think of any other way to describe it." So he seemed to really enjoy, and the way he describes it, how if you let go of certain controls or just sort of back off a certain thing or turn the wheel a certain way, it'll just sort of go back and do a quick hover. It sounds a lot like the way drones, and I've piloted some small drones. I'm certainly not even a drone enthusiast, but flying a drone was very easy. I had a DJI one. I just got rid of it recently, but I'm considering a different one. But in general, they're super easy to fly. And when you do certain things, they sort of go back to like a neutral, like a hover, and they're programmed to keep everything. Like, you're not going to crash a DJI drone unless you try, especially if it has some sort of obstacle avoidance. And it sounds kind of similar with the Joby Aviation. So yeah, really interesting. Like I said, I don't obviously have any experience flying or even being in a simulator, but the way he describes it sounds like the future. It sounds really safe. It sounds really intuitive. It sounds really simple, which seems great.
Again, the Part 23 regulation change is going to bring up a number of pilot interface, aircraft performance changes that we haven't seen in 50 years, 60 years, in terms of how aircraft work, what they do, what they look like even, is going to change dramatically because the regulations have loosened up on them. I think as we go through this process, we just got to keep in mind we're still dealing with humans and human reactions, like Boeing went through on the 737 on the Maxes. And I saw an article about the Max today, which was written completely incorrectly about what actually happened there. But the human reaction was part of the reason they had problems. Again, you got to take that consideration. So you only learn that through thousands of hours of flight time. So Joby's going to learn, and I'm really anticipating to hear more and more about how the aircraft flies, especially as you're getting into people flight test.
Well, that's going to do it for this week's episode of the Struck Aerospace Engineering Podcast. Thanks so much for listening. Be sure to subscribe on iTunes, Spotify, Stitcher, YouTube, wherever you're listening or watching. Leave us a review or leave us a comment. Love to hear from you. So thanks again. We'll see you here next week on Struck.
Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.